Hi guys, so today we are going back into Lua and the Love Engine, and we're going to make kind of a simplified board game. Um, we're using Rebel.it, which means that you can do all of this directly inside of your browser without having to install any extra software, which is pretty cool. That being said, you're going to see some lag and things like that happening, or at least I did last night. So you may eventually, if you're just kind of dabbling in this, Rebel.it is great. If you're wanting to actually build something to release, you're going to want to probably download Love and Lua on their own. So again, this is meant to be pretty beginner friendly. So that means that there's going to be a lot of, if you're a more advanced programmer, you're going to see things like, why am I not condensing that into a function, or why am I doing that twice, or things like that. And that's because it's meant to be more on a super beginner level. We are going to touch a little bit more kind of intermediate things than we did in the last one. So we'll get to that. We'll do some for each loops again. We'll do some else if statements. We'll do some tables. We'll get a little further into like messing and manipulating with indexes, things like that. So yeah. So basically what we are building today is this kind of board game setup. And when we click the spacebar, yeah, okay, so see, you saw that little bit of lag. So that's actually made two moves. So when we click the spacebar, it's gonna change who's moving, and basically we just keep going through. And like I said, so I don't show you how to make special tiles based on the tile color or anything like that, but that would 100% be something that would be, could be easy to implement, or it could be hard, depending on what you're wanting to do with it. But this will show you kind of how to make that, and it'll show you, when player 2 wins, there you go. They win. Awesome. Pop up. So, and that's all this is. And again, this is really simple. It's not really, a full game, but at least gives you somewhere to start with. And again, I will link this code, and I will comment it a little bit better before I do. But we're going to start from a brand new, fresh kind of setup. So, but, yeah. So, with that said, where did I get the dice and the or the tiles and things like that? All of that came from KinneyNL. So, KinneyNL is a great place. They have a CC 1.0 universal license, which means that basically you're free to use it no matter what, and you don't have to give credit. But let's be real here. Give credit where credit is due. They made you something, you're using it, and they're giving it to you for free from the kindness of their heart. The best thing you can do is say, hey, yo, these people helped me make this. So do that. And again, if you're finding yourself using a lot of Kenny stuff, donate, or they actually have buy packs as well. So the packs that cost money are really good. So, shout out to them. But basically, I use this for my different tiles, so the blue, the green, the red, and then this one with the little diamond on it. And for the board game stuff, which is kind of the majority of what I used their board game pack. So if we click assets, go to 2D, and we do board game, you're going to see the board game pack. And this is where we get the dice, this is where we get the little player characters, and if we were using anything else, this is where we get it from. So, yeah. And these come in multiple different colors, so you don't have to worry about only having yellow. So, with that said, I've created a new REPL, and I've added in, by just dragging in, my dice, my players, and then my tiles that I want. And I renamed things so that it made more sense. So each of these are the number for the dice, this is the color of the tiles, this is the color of the player. Remember to name things that you can spell, and things that make sense to you. So, as always, because we are in Love, there are 6 major lines that get used for every single Love program. And those are our function, love.load, end, function, love.update, dt, And this one we're not really going to use DT, but it's good to get in the habit of putting it there, just so that you have access to delta time. Those that don't know, DT stands for delta time, which is the time that it takes between frames, basically. So the change in time. And that's how we use it to make sure that things are consistent and not dependent directly on frame rate, but on actual time. And then function love.draw and end. So those are the three functions, 6 lines that kind of comprise every love game, or the basics for every love game. So with that said, we've already added in all of these, and generally if you followed the last one that I showed, what we did was we did separate things for each item. So we did, we loaded 1 image, we loaded 2 images, we loaded 3 images, we loaded 4 images. We're going to do a little bit different here insofar as we are going to load things as tables. So we're going to say die, which is a single for dice, equals, and then we're going to make a table. We're going to make a table of all the different dice. So to make a table, we just use these guys. Those of you coming from other languages, tables, they work a lot like arrays, but they can also work like dictionaries or lists. So they can have an index value that you give them. If we don't state the index value, it automatically goes with what we think of for an array, except that because it's Lua, Lua starts their tables at 1 and not at 0, which most languages start at 0. So we're going to do love.graphics.newImage, and then we're going to say die_1.png. So that's how we load an image. And the way that Lua works, or the way that Love works, is that we have to load the images here. We can't just directly draw them from over here. We have to say, hey, we want to use them. If we don't say we want to use them, then they don't exist. So I'm just, like I said, I copied that, or I didn't say it, I copied that, and what I'm going to do is I'm just going to go ahead and paste and manipulate, because life makes it easier. So why am I doing it this way? Well, because it's going to make it easy to call the index and call up the dice number. So if, we roll die, or we pick a random number between 1 and 6 for the die, and it comes up with, 4, we can say, hey, pull the thing at the index 4 of die and pop it up for me. So it's going to make life nice. It's going to make life easy, like pasting things well. And so you're going to see there's going to be a lot of me being at least vaguely silent for a few pieces in here, because a lot of this is going to be pretty typing heavy, because we're going to use a lot of extensive tables, for lack of a better term. So we say we've got our die. Yay, life is good. And the same way that we did this, we're going to go ahead and do our tiles. Not because we need to do our tiles this way, but because, again, we're going to do kind of a randomizer, so we're just going to call from this list, and it's going to be a lot easier to say, hey, pick a random number between 1 and the end, or however long our tile list is, and then go ahead and draw whatever is at that index. So I'm going to call it tiles, because it's multiple tiles. And we're going to say, hey, that equals, and again, our little curly brackets or French brackets, depending on who teaches you. And we're going to do, again, we can just paste this guy because it's the same thing. But instead, we're going to say, hey, this is tile_blue. And it helps if you spell. Remember that Lua is very, very, very dependent on your spelling and your capitalizations, so make sure you spell things that you know how to spell. Or, not that you know how to spell, that you can spell easily. There are words, doesn't matter who you are, there are words that, trip you up every time. So, make your life easier and use words that don't trip you up. Because nothing is worse than trying to track down spelling errors. To be entirely honest, for some languages, it's, the absolute worst. Especially for things like Lua, where you can technically, you don't have to to give a value. So when you actually create a variable, you don't have to automatically give it a value. It automatically assigns nil. So suddenly you can say, hey, I want to use this thing called, like up there where I said tile underscore BLE instead of BLUE. If it was a variable name, it'd be like, hey, so this thing. Okay, cool. This specific code wouldn't work because it doesn't know what that is, but you could inevitably create something that would be like a true false, that it would suddenly like treat it like it was an actual thing. So yeah, all sorts of spelling problems today. And with love, you can either keep this last comma or you can delete it. It doesn't really matter. It doesn't really care. So yeah, so we've got our die and our tiles, and those are all in. So the first thing we're going to do, only because it gives us a place to start and to see what we're doing and how this is going to work, is we're going to start with our dice and rolling our dice. So to do that, if you followed along with the last one where we did the chicken drop game, we had this idea of a special function for the mouse press. Well, Love has a couple different ways that you can check whether a key has been pressed. And the big two, or the big one that I think is the easiest to use, is definitely the function that's on its own, rather than the one that uses, or that we can use directly like inside of other things. So just like with the mouse press, we're going to do between load and between update, we're going to say, hey, function, and then we're going to say love.keyPressed, and then the one parameter it's going to take is the key. And remember, everything always has to have an end, so we're going to go ahead and end that before we start typing the stuff in the center. And what we're going to say inside is we're going to say, hey, if the key, so if that parameter is equal to space, and if it was like the A key or anything like that, you put A or B or C or QASD, or you'd put up, left, right, down for the arrow keys. So it'd be like that. Then, and again, remember, because it's an if statement, we have to have the end. And technically what we want to do is we want to say, hey, we want to take the dice roll so, and I haven't put this into up here yet, but what we can do is we can actually start off with saying, hey, dice roll equals 0. Eventually we'll put that there, but just to keep things simple so that you understand, like I said, we could just start this here. We're going to say dice roll equals math.random and then 1, so that's the first number that we wanted to look at. And we have a couple different ways that we can get the length of a table. The one that's the easiest to use is going to be the number sign, pound sign, hashtag, however you want to call it, die. So that says, hey, give us the number of elements inside of die. Now this is where it works great for having that list, dictionary, table, array start at 1 rather than at 0, because we don't have to do any kind of manipulation to say, hey, you know, subtract or add or do whatever to get the actual sizing. So we can do that. Now, the issue with just doing this, again, if you watched the last video, this is information that you already know. If you haven't, information. Lua's random and C's random, because they're kind of built in the same thing, are dumb. They are beyond dumb. So basically what Lua says is, hey, so yeah, I created this list of random numbers, and that's going to be the same random numbers every single time you call random. So yeah, maybe it's like 1, 4, 9, 12, 13, 24, something like that. But every time you run me, I'm going to start at 1, 4, 9, etc., etc. So every time you play, it's going to be the same numbers. So what we have to do is we have to actually randomize random before we can, call it random. So to do that, there's 2 lines of code that we use, and that's math.randomSeed. So that's, hey, create a new table of numbers for us, and we're going to say os.time. So this looks at your operating system's clock and uses those as kind of your random seed. And then, because of the way that random works, we kind of have to get the old random stuff out and get random restarted. So the easy way to do that is to just call random a few times. As you can see, I've got people playing Steam, and I should have turned Steam off way before I started this, but oh well. So math.random, math, and make sure that you're doing that. And then math.random. Of course, cards are going off. Why would this be a nice, easy thing? So, now for sure, random is actually going to work correctly. So now we can say that this is going to work. So if you wanted to test, you could actually print out dice roll, and we could run dice roll and see how it was actually doing. So if we say, hey, print dice roll, we can run it, and if I haven't done anything wrong, which, could happen. It does. If you watch the last video, it happens more often than I'd like to say. And right now it's showing nothing. But if we click it and we click the space bar, it's telling us that you clicked space, but I'm not actually giving you what you're supposed to be giving. Okay, there we go. So we have the 1, we have a 5, we have a 2. So we're getting pretty good. We're randomizing numbers. So occasionally, random numbers means that you'll have some repeat. But so random's working. That's all we needed to do, right? We just needed to make sure that random was working. So now what we want to do is we want to draw the dice when we roll the dice, right? That kind of makes sense. So the first issue that the first issue is that we have to start out with the dice not being anything. And so there's a few different options. You could start the dice on some sort of random number and work it, or because we've already set dice roll to 0 here, we can create an if statement inside of our draw to only show the dice when it's actually been rolled. So what we can say is hey, if dice roll is greater than 0, then, and remember end, and then we're going to say, hey, love.graphics.draw, and then we're going to take die, and we're going to take whatever dice roll currently holds, and for now, we're going to pop it at 0, 0. It doesn't have to be at 0, 0. It can be wherever you want it to be, but for now, we're just going to keep it at 0, 0. And we can run, and again, we have a black screen, but when we click the space bar, you can see we rolled a 1. And we click the space bar again, we rolled a 4. We rolled a 5, we rolled a 3, etc., etc., etc. So we now know that that's working. So this is all good. So we have our dice working. Yay! And now we're not going to touch the dice for a while. So there are a few different ways that you can make your paths, or your maze, or your board game path, however you want to call it. And it just kind of depends on how you want to do it. We're not going to procedurally generate. We're not going to create a random path because that requires a lot of extra things. So we're going to create our own path. Now, the first thing that we need to do is we need to figure out how big our tiles are, or how big we want the tiles to be on our screen. So if we go in, we can see that these tiles are 64 by 64. So now we're going to do some math. Dun, dun, dun. Technically, when we divide, and we know that this window the actual playable window for Lua for Love is an 800 by 600 window unless you manipulate it. So if we're taking just the standard window, 800 by 600, we can say, hey, what is that divided by 64 on both sides? So we know that we can fit, it's 12.5 by 9.375, I think. So we know we can fit 12 and 9, or 12 by 9. And yeah, we're going to have a little bit of offset that we're going to need to deal with, but we know we can build 12 by 9, that's basically our playable area. Now, this is where grid paper comes in really handy, but because we're in the age of computers and nobody actually owns graph paper anymore unless you do, I do, but one of the things that you can do that makes life easy instead of going and finding like a random grid thing is to pull up a Google spreadsheet or Excel or whatever you have available for you, OpenOffice, and you can create your maze or your path, because this could work for a maze too. And so this is what I've created. This red and green area is going to just be kind of dead space, and that's in case I wanted to do something special with like things getting on and off of the things, that kind of stuff. But basically we're going to translate this into text. So, but the first thing we need to do is we need to say, hey, we know that because we have that extra like 0.375 on the vertical and 0.5 on the horizontal, that to get this to be actually centered in our screen in our 800 by 600, we're going to need to kind of pad out or offset where we're going to print our tiles. So to do that, we'll just come down here underneath dice roll and we're going to say, hey, offset horizontal is equal to 60. And that's because we have 0.5 tiles left, and 0.5 tile is 32, because that's half of 64. And so if we want it to be padded on the left and on the right, that's going to be half of 32, which is going to be 16. So in the same way, we can say offset vertical is equal to 12. Just go with that math. And yeah, this is hard coding in values. That's not exactly the best thing to do. Yeah, it's not exactly the best thing to do. We could do something special like find the width of the tile and do this and do that, but because we know and we are building this in such a way that it will only work with 64 by 64 tiles on an 800 by 600 play area, hard coding is not your worst idea. So yeah, so we have those red and those green areas. So let's go ahead and put those down really quick because they're not anything special. So we can just go ahead and draw them in our draw functions. So before dice roll, because we want our dice to be able, if it's going to be in that area, we want it to show on top of it. We can do our left rectangle. Remember, 2 little dashes is your comments here. And what we're going to do is we're going to say, hey. So the first thing we want to do after, or like before we go to dice rolls, we want to make sure that because we're going to be changing colors, that here we say love.graphics.setColor. So that's when we're going to set the color is 1, 1, 1. So we want to make sure that there is no extra color overlay on top of the dice. So now we can go back and we can say, hey, we know that we want the left area to be kind of red and the right area to be kind of green. So love.graphics.setColor again. And in this case, we're going to put 0.3, 0, 0. And you can go look at RGB charts and things like that. You just need to divide whatever number it gives you by 256. 256, and you'll get the values that go into this because it works on a 0 to 1 value rather than a 0 to 255 value. So and then we can say love.graphics.rectangle, because that's all that is a big rectangle on the left and the right, and we're going to say we want it to be filled and not just an outline. We want to start it at 0, 0 for the top left corner, And then we want to make it, the width is 64, so that's one tile, plus our horizontal offset. And then for the verticality, we want to do it the whole screen, so there's actually a built-in function for that, so we can leave love.graphics.getHeight. And that's a rectangle. And then for the same thing, we can just go ahead and copy this. And we can say, hey, let's change this from red to green, so 0.3. And then we're just going to change how these are. So instead of that, what we're going to have to do is we're going to have to say, hey, we want to offset it from the other side, and so we want 64 plus the offset away from that edge on the right. So to do that, we're going to do love.graphics.getWidth. So that'll get us that 800, or that 800. And then we're going to subtract from that 64 plus the offset horizontal. And remember, this guy needs to be in quotation marks, in parentheses, because otherwise it will evaluate left to right. And we want this to be added before we subtract it. And then for our vertical, again, we just want love.graphics.getHeight. And we should be good to go. Now to test this, we can click run and we can see if I've managed to mess anything up. Again, because you guys, those of you who watched me last time will know I misspell things all the time. Ooh, I have definitely messed up something. I have definitely created a green square that goes all the way across here. So that's something wrong in here. And that is because that would make sense. That's because I put 0, 0 for it to start at, and that's not what I needed. I need that to be our start point. And this is still going to be our 64 plus offset each. And this is why testing as you go is such a big deal. When I teach this class, I have a lot of students who go through and they code a lot. Why aren't you working? So I have a lot of students who go in and they code a lot of things without testing first. And then it comes to the time where they've got to test and every single thing is broken. And so it's a lot harder to find derp to derp, because I messed up the order of everything. It's a lot harder to find where you've messed up if you're having to shuffle through 9 million errors, especially when it comes to graphical things where it's actually drawing and doing something, but you just can't figure out where it's drawing it or what it's doing. So yeah, so now we've got our red and our green bar, and again, if we click the space bar, you can see the dice is up in that corner. I'll eventually move it to down over here, but you could leave it up there if you really liked it up there. It just kind of depends. You could even technically use these as your player 1, player 2, and you could put 2 different dice if you really wanted to. I'm going to show you using 1 dice, but that doesn't mean, that doesn't mean that you're not going to change it later on. Because that's the point. This is just to give you a basic idea of how to do this. This in and of itself isn't really an exciting game or anything like that. So, now, how do we do our maze? Well, what we do, if you guys kind of know how ASCII art works, where, letters represent things, we're kind of going to do the same thing. We're going to say, hey, this is going to be a 0, this is going to be a 0, this is going to be a 0, this is going to be a 0. So the things that don't have anything in them, we're going to call 0. The things that maybe we want, we're going to maybe call our start and our end some sort of special number. So in this case, I call them 3 and 4. And then all of these other ones, we're just going to call 1. And we're going to space it out so that it actually matches to what our thing is going to look like. And because I don't want to take the time, it's not that I don't want to take the time, I don't want to take your time typing all of this out. I'm going to go ahead, and I have it already written down for myself. So we're going to go ahead and we're going to look and we're going to see. And you can put this wherever you feel like putting it. But I'm going to go ahead and put it down below the stuff that we already have. So down below dice roll, offset, V, etc., etc. You could put it above here if you really wanted to. It just kind of, you know, it depends on where you want to put it. And there's no right or wrong place to put it, not really. But it just kind of, yeah, it just kind of depends on where you want it to be. So I'm going to go ahead and put it here. And I'm going to call it map setup. And we're going to basically copy this table a few different times. And yeah, we could base everything directly off of this one table, but I'm going to show you how to add things so that we, instead of adding these numbers, we're going to put the actual tiles that need to draw and things like that. And that's not to say that you can't do it all off of this one kind of table, but it's going to make it easier to have multiple storage places. And we'll see why in a little bit, especially when it comes to like actually directing our players through our path. So yeah, so like we can see, all the things that don't have anything in them are 0s. The start path is 3. The actual path, and you can see here where it highlights it slightly, all of those are 1, and I guess I should make this a little bit bigger. All of these are 1s. And so basically it's just a text representation set up in a table, and that means that we can actually check. We can say, hey, so index 0 is going to be a 0. Let's say index 14, that's going to be where our map starts, etc., etc., etc. And this is going to help us when we actually go to draw it, and when we actually go to say, hey, put tiles where they need to go. For some of y'all, well, why aren't we doing a 2-dimensional array or a 2-dimensional kind of thing? And I guess, yeah, we're just not. We're just going to go with we're not. This is much easier to work with. And 2-dimensional arrays are kind of a weird thing inside of Love and Lua. So, after we've done that, we're going to duplicate it. Literally. Like, it's going to be the same exact thing. But the reason why we're duplicating it, and we're going to call it, instead of map setup, we're going to call it graphics setup. And this is going to hold our actual tiles. And so right now, and when you're looking at it, it's going to look exactly the same. But what we're then going to say is we're going to say, hey, replace some of these values. Because in Lua doesn't have any problem with you mixing different types inside of arrays, or inside of tables. Whereas some other languages, your arrays can only hold one type of language, or one type of, wow, I can talk today. It can only hold one data type. Lua doesn't care. Lua is the kind of thing that you can even change one thing from one data type to the other without it batting an eye. So, we're going to put our tiles in instead. Again, we're going to need to use random. So we can start it at our load, and we can say, hey, math.randomSeed os.time math.random math.random, math.random. Now, always remember this last set of parentheses. It is probably the number one mistake I see of people who are trying to use random is that they'll forget those last parentheses and then they can never find what they did wrong. And it's literally that simple. And as you've seen with the mistakes I made in the drawing thing, a lot of times your mistakes are really simple. Like, really simple. But a lot of times our brain thinks that it's smarter than our actual eyes, and so it fills in mistakes. It says, hey, yeah, I know you made that mistake, but I know what you meant. So it's really hard for us to kind of debug our own stuff. But that is something that the compiler will catch. So now we're going to use a for each statement. Those of you who have used for each statements in other languages, it's literally like for each item in this array or list or thing, then do this stuff. It's slightly different inside of Lua, and because we're not giving our index values, like because we're just keeping it, we're not doing like actual pairs like you would do with like a dictionary, it automatically sets up our indexes as 1, 2, 3, 4, etc., 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 etc. So for that, we have to use what they call I-pairs. So we're going to say, hey, for index and value, so that's whatever the index is, and then what's held at that index, in I-pairs. So that's what they're saying. They're saying, hey, if it's index paired versus like us actually physically saying what the pair is, then we're going to say which thing we're looking at, and we're looking at graphics map. Do. Sometimes auto-completion is good, sometimes it's not. And again, you're going to have an end statement. And this is where it would probably make more sense for us to use else-if statements. And I made a huge point in the written version of this that I didn't want to use them because they tend to confuse a lot of people. Like, people understand if statements and if-else statements, but once you start adding in else-if statements, that just, it's mind-blown. So I'm going to keep with what I have in the document, but note that you could write this with else-ifs or if-else statements or else-if statements depending on the language you're coming from. And it's probably more efficient to write it that way, but just to like give you a hint of what we're doing, we're just going to use if statements. So if graphics map at I. So it's going to go through the entire graphics map table, and it's going to just increase I every time. So the first time it goes through, it's going to be, hey, what's this thing at the first element? So it's going to look at this. And the next time it goes through, it's going to look at this one. And then it's going to look at this one. And it's just going to keep going until it gets to here, and it's going to like fall out. That's when it'll stop looking through everything. So we're going to say, hey, if that is equal to 3, so that's our start tile, then, and remember we have to have an end statement, we're going to say graphics map I. So if it is 3, then change the value that's there from that 3 to equal whatever we want it to be. And in this case, we're going to do tiles 2, which will, if you come up here, you can see it'll give us the green tile. And that's all we need to say. And then we can go ahead and we can copy this, because basically we're doing the same thing for the other two things. And we want to say if graphics map I equals 4. So if it's the end tile, then we want it to show up as that orange tile. And then we can say, again, one more. If graphics map I equals 2, so if it's any of the path tiles, then we want it to be random. We want it to choose whatever we want it to be. So we want it to say, hey, pick from the tiles list. So pick from 1 to number tiles. So there we go. And we can leave it at that, because we don't need to replace those zeros. We don't care about what's in those zeros. 0 is nothing. We could replace it with nil if you really wanted to replace it with nil, but we don't need to even address it because we're just gonna say we just want these 3 things. So we're just gonna look for these 3 things. So there we go. So technically our table is now saved with all of the tiles that we need it to be, and we need it to start drawing. So to do that, we're going to actually go ahead and create draw points because we don't want to change these values. We want this value and this value to always be 16 and 12. And what we're creating with the draw points are values that we can change so that we can shift every time we draw. We can say, hey, go through this table and at this one, draw it at this first point, which would be our 0, 0, which is going to be 16, 12. And then add 64 in the horizontal and draw this one. And then add 64 and draw this one and this one and this one. So we don't want these to change. So what we're going to do instead is underneath here, after we've done all of this, is we're going to create, and you could put them really anywhere. You could put them up here if you really want to put them up here. I put them down here since this kind of goes with our graphics thing. And we're going to say draw point X equals offset H, so that's its initial value, and draw point Y equals offset vertical. And that gives us a place, like I said, our 0, 0 to start drawing. So down inside of our drawing, and again, remember that our dice roll is the last thing that's going to happen, but we also want to make sure that our board game, like our actual board pieces, are going to be white. So let's go ahead and put this below that, but above our dice roll. And I guess technically you could put it above the dice roll. It really depends on how you want to do it. We're going to go ahead and put it wherever you want. I'm going to go ahead and put it at the end, because I know my dice is always going to be on top of the board, or it's going to be in an empty area. If you didn't quite know where you were going to put your dice, or you're going to randomly like throw your dice at the screen, which might be kind of cool, then you would maybe want to put it before, because you always want your dice to be on top. So we're just going to put it down. Well, I'm going to put it down here. So we're going to say, hey, for IV in I pairs, graphics map, do, and end. Everybody wants to come to the party today. And we're gonna say, as long as it's not 0, as long as the thing that's inside a graphics map isn't 0. So if graphics map I does not equal 0, and to do not equal, we're going to do the little squiggly equals 0, as opposed to exclamation point equals that you're used to in other languages. Then, and again, we're going to have an end. And if you just wanted to see how it was worked, you could, technically what we're going to do is we're going to say, hey, draw the thing. Love.graphics .draw graphics map I, and then we're going to say draw it at draw point X and draw point Y. And then after it's fallen out of here, or even if it is a 0, we want it to always increase our draw point X and eventually our draw point Y. And so we're going to come down here, we're going to say, hey, draw point X equals the current draw point X plus 64. And that'll give us the new place to draw the next thing, the next thing, the next thing, the next thing. Now, the issue is that right now it just draws it in a horizontal line forever, which means that we would never see anything because our first line is all zeros anyways. So, what we have to do is we have to say how do we get it to go down vertically? And to do that, there's a few different ways, and there's different thoughts on how this is best accomplished. But the way that I like to teach and the way that I like to use is using the modulo operator. And for those that don't know, the modulo operator is literally like division, but instead of returning what something has divided by, or like what we think of as actual division, it returns what the remainder is. So 10 modulo 3 would return a 1, because 3 goes into 10 3 times, so we get 9, and then we have that one remainder that generally we would say, hey, 3.333, so on and so forth. In the same way, if we do 4 modulo 2, it's going to be a 0. This is a great way to find odds and evens. So an odd number that's modulo 2 will always return a 1, whereas a even number will always return a 0. So in this case, what we're doing is we're looking to see whether we've gone the 12 across that we know we need to go across. So we need to say, hey, if the index that we're at divided by 12 doesn't have a remainder, then set our draw x, so set ourselves back at that first point of draw x and go down one new line. So to do that, underneath this draw point equals blah 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 blah, we can say if math.fmod, and there's a few different ways to do this, but math.fmod is probably the easiest. I'm going to say I, so if our index, and then we divide it by 12, comes out to 0, and remember it's an if statement, so we can say end. We want to reset draw point x to what we're calling 0, which is actually our offset h. So offset h. And we can say draw point y equals draw point y plus 64. Now, this seems all fine and dandy, but if we were to run this, it would actually break. Well, okay, it wouldn't maybe break, but you would never see anything. Because draw actually is drawn every update, so right now, ooh, and I spelled that wrong. We'll see, there will be probably at least one error inside of here somewhere. But what we'd see, if we could slow down time, because draw is drawn every single frame, is that we never reset draw point x and y back to their original kind of setup. So they're just going to add on the next loop they go through and add on the next loop and add on the next loop. So basically it would start here and then it would suddenly fall off really fast. It's the same way that we do animation. Like literally that's all it is. So what we have to do instead is we have to, after we're done with everything, is we want to make sure to set it back. So we're just going to say, hey, draw point x, go back to offset h. And draw point y, go back to offset b. Now, we should be able to press the play and we'll see if there's an error, or if I've done something and missed something. Aha! So, I don't know that you guys can read that. It's telling me, hey, there's an error in line 55. Ooh, so that's like way back there. Let's see. Let's see what I did in line 55. So line 55. Ah, so I'm missing... Oh, I didn't write math.random. So we can stop and we can run. And again, for those of you who have followed me, the errors up here are way better to look at than the errors that are down here. These errors tend to make more sense. Okay, 47. Oh, graphics setup versus graphics map. Um, Inside of Rebel, if you right click something, you can actually select all the things that have the same name and it'll change it all together. And again, you know, this is 93. This is kind of the whole point. Okay, the graphics setup I. Graphics setup I. Okay, so I paused the video so I could see what I did, and the answer is I don't know math. Up here I have 3, 4, and 1. I'd have this as a 2, and what I had to put it at was a 1 because apparently I decided that 2 didn't exist in this thing. So that was it. That was the only problem I had, was that 1 that was right there. So now that that's fixed, all of this works, everything is great, I promise. Just make sure that you have 3, 4, and 1 if you're following directly along. We can click run, and you're gonna see our beautiful map. Cool, right? And if we stop it and if we run it again, you're gonna see a different map. So now we have all those tiles, and that's how our random works. Like, is it something special? No, not really. But it is pretty cool. Even, even though it's the same path every time, you can randomize the tiles, and maybe you make each tile have its own kind of rules, so it makes it harder to get through the maze. Or the maze, through the game. Or you add in cards or something like that. So, yeah. There's a lot of things you can do with it, but it's just a kind of a cool visual, but it also can help you mechanically. So, now that that is done, and I'm so sorry I had to do that, and that I apparently can't count, we are going to talk about how we're going to add our players in and start moving our players. So again, real talk here, this would be a lot better if you created functions so that you only had to have one function and it moved each of the players, but we're not going to do that. We're going to basically duplicate the code twice so that we have the code for each player, and the reason why we're doing that is just so that you can get the basics down so that you can understand how this is working, and maybe later, once you understand the code better, you can start saying, hey, well, I know this would be more efficient if I switch this over to a function, and I'm going to try and make another video that addresses that, but we'll see. So, I put the players in, and we know the players are over here. They're player green and player purple. And I'm going to come up to the top of load, and before anything, I'm going to go ahead and just load these guys in, and we're going to say, hey, player 1 equals love.graphics.new image, and then player purple.png, player 2 equals love.graphics.new image, player underscore green dot png. And another reason to do this as like a function instead is that it would mean that you can make multiple players and it would be easier. But for now, again, we're gonna, because this is a basics, we're treating this as this is like one of the first programs you're writing, or the first full kind of things that you're doing, which a lot of times, if you're coming in brand new, and a lot of my students are coming in brand new, they don't really have a grasp at functions or methods, and so those just get more confusing and they get in the way of understanding. So yes, you need them, and yes, if you're going to go on to your life with a beautiful life of programming, functions and methods and new classes and extra files are going to be your jam. But for people who are just starting, a lot of those things can be really daunting. It's like languages in and of themselves. You know, C spot run before we start talking about something C as the wind blows, spot miraculously walking through the blah 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 blah, blah, you know. We're wanting that first step rather than something complex. So now that we have those there, we're going to go ahead and we're going to start making a whole bunch of variables here. So we're going to make player 1x and player 2x, or player, well, I'm going to do player 1y. I'm going to switch them together. And then we're going to do player 2x, player 2y, and I'm going to set these to 16 and 64. Now those of you who are actually watching or have been listening are going to be like, wait a minute, why don't we have the offset? That's really helpful, Self. Why don't we have the offset on our y? Well, you know, why aren't we going down that extra 12 places? And that's because I kind of want the token to be in the center rather than to be edged or aligned with the bottom of the actual tiles that we're walking on. To do that, I just leave the offset off, and it pushes us to where basically the center of the tile is. So that's kind of the logic behind that. And yeah, I don't honestly expect you guys. You could put it at the bottom. I'm not expecting anything. To be entirely honest, if you've followed me this long, I'm thankful. Yeah, I'm very thankful. So down at the bottom of draw, we're going to actually draw our players. And we're going to say love.graphics.draw. And we're going to draw player 2 first. And the reason why we're doing this is because, again, I'm only showing you guys the real basics. So at this point, we're going to have player 2 and player 1 be one on top of each other. So to begin with, you're only going to see one player until player 1 moves. And then we're going to say love.graphics.draw, player 1, player 1x, player 1y. And now if we run, again, you're only going to see the purple player if I name them right. And again, if I haven't done anything wrong, which is always a possibility. Okay, so we have our player. He's right off of that first tile. Life is good. Now, again, like I said, you could make some nice visuals where you kind of pushed them off to the side and everything, and then automatically had them go there. But we're just going to keep them right here just for logical and simplicity's sake. So, at the very base of this whole kind of idea of movement is that we need to have, hey, is it player 1's move or is it player 2's move? And we're going to do this a little weird, and some of you are going to be like, wait, but we could just use one variable for that. But we're going to go ahead and make two. We're going to say player 1 move equals false, and player 2 move equals false. And this is going to keep it so that we know that that dice roll has happened specifically for that one player, and it's also going to help us to control the dice so that it doesn't roll, you know, that you don't spam the space bar. So for now, to start with, we're going to get player 1 moving, because once we get player 1 moving, player 2 is going to be relatively simple. And we're going to come into our space, and we're going to say, hey, if we press the space bar, then player 1 move is going to equal true. Simple enough, right? That means, hey, if I press the space bar, it's time for player 1 to move. So what are we going to do with player 1? Well, inside of update, this thing that's been very lonely, for now we're just going to move it horizontal so we can see how it's going to work. We're going to say, hey, while player 1 move, so while player 1 is true, or player 1 move is true, do, and again this requires an end statement, player 1x equals player 1x plus the dice roll times 64. Because of orders of operation, it's going to say, hey, move this many tiles over plus our current position that we're at. And then we just need to say, yeah, player 1 move, it's back to false. And then when we run it, again, if I haven't written anything wrong, and we click the space bar, you're going to see we moved technically 1, 2, 3, 4 spaces over. So we click the space bar again, and we got another 4, so 1, 2, 3, 4 spaces over. So we know that that's working. Now, you know, we can't just move straight across. I guess you could if you wanted to just have a straight across thing, and you could make some sort of challenge out of it. But we have like a full-on kind of funky map that goes different directions. So the way that you automatically would think that you need to do this is you need to say, hey, let me check and see if I can go this way. Let me check if I can see. Let me check which way I can go. And for a lot of us who are used to things like a character movement, it's just, you know, hey, check if something's in front of you that you can move on and move to there. Or check if something's to the left of you and move there. Or check if something's behind you and move there. Or check if something's up and move there. But the problem is that with those orders, we have a certain order of the way that things go. So if we got to here, we could say, let's say if we checked left first, that's fine. Or if we checked right first. So if we checked here, yeah, there's nothing there. Then we check down. Okay, great. So now we know that our first check is always going to be to the right and our second check is always going to be down. And we come down here, and so the first check is to the right. Okay, so we keep going. Say the first check is to the right, the next check is down, and then generally you would say, hey, check to your left. And it's going to say, yeah, I can go to the left, so it's going to go here. And then you're going to get stuck kind of bouncing between these two. So what we need to do is, there's a few different ways, and for some people may want to do it where, hey, you create whatever is pointed front, and then you move to the next, like, kind of what's pointed front. But the way that we're going to do it is we're going to create, wait for it, another table. Now this table is going to tell us which direction we can go. So, or which direction the next tile is in. So it's kind of handy insofar as it's a directional kind of thing. So the first thing that we want to do, though, is we also need to find out, you know, well, where is this character on our table? And we could 100% draw a table and add the player in and do collision checks, etc., etc. But because this is a very specific example where we know that everything is 800 by 600, we know where the tiles are, we know how that's going to work, we know that when we start, so this tile right here is tile 13. So we are going to hard code it in, which is not a good thing. Not a good thing. Not a great thing. And we're going to come over here and we're going to add player 1 index equals 13 and player 2 index, equals 13 as well. Again, we're doing this because we can hard code, because since this is never going to change, it's only made for an 800 by 600, we're not allowing it to be able to scale or add more. And again, it would be nice to make it so that it would be dynamic if you change the size. But for now, because we're literally already at the hour point, we're gonna keep it simple. We're gonna hard code it. And for those of you who are programmers or like big programmers, it probably hurts. I'm sorry. Too bad. So sad. So, we're going to go ahead and we're going to make a flowchart. Basically, we're just going to copy one of these guys, and you can put it before you setting this up or after. It just depends on where you want to put it. It really depends. I put it with this just so that I can have all of my stuff together, and we're just going to, technically you would just copy this, and then you would say, hey, okay, so where are each of them going to go? But again, because I already have it written, I'm just going to copy it from over in my other file. And so what this is saying is if you're standing on these blocks, which way do I need to go? If you can move right, it's going to be a 1. So standing right here, you can move to the right. So it's going to be a 1 in 13. So a 1 in 13. So standing here, it's also a 1 because we can go over here. Now once we get here, we need to go down. So this one's going to have a 2 instead. So it's going to be a 2, a 2, a 2, a 2. Oh, we get to here. We need to go back to going to the right. And I think I said left up here. I'm bad with directions, guys. So if we're standing here, we need to go right. So it's going to be a 1 again. So 1, 1. Oh, this one. We need to actually go up from here, and we haven't written that direction yet. So we're going to do that as a 3. So this is going to be a 3. This is going to be a 3. We're going to go back to 1. This one's going to be a 3, a back to 1, to 1, to 1. Or not 1 there. A 2, 2, 2, 2, 2. And then this one is going to be a new number. It's going to be 4. So 4, 4. Then we need to go down. So we're going to go 2, 2. Then we need to go to the right. 1, 1, 1, 1. Then we need to go up. So that's going to be 3, 3, 3, 3, 3, 3, 3, 3, 1, 1. So there we go. That's it. That's how we're going to do that. And so that's literally what this one is set up to say. So you can see we've got our 1s that mean to move to the right, our 2s, which means that the next move that you need to make is going to move to the next tile is down. 3s are up, 4s are to the left. And so now we can say, hey, check where our index is and check the index inside of here. If our index matches, whatever's in here, move in that direction. Is it 100% like the smartest way to do it? No, but it is definitely pretty foolproof. So as long as you can, and again, this is hard coding, so you would have to hard code for each maze you make, those kinds of things. But it's not the worst thing in the world to do. So, now that that is said, we also need to talk about a move counter. Because basically we're going to have to say, how many moves do we have to make, and we're going to count down. Because what we're going to do is we're going to move the player 1, we're going to move the player 2, we're going to move the player 3, we're going to move the player 4, etc., etc. So we can't just use the dice roll, because that would basically automatically roll it would change dice roll, and since we have dice roll being like reset every time, it would cause problems, and would also mean that our dice didn't show when it went down to 0. And because this is going to literally happen instantaneously, because we haven't said, move 1 and wait, move 2 and wait, move 3 and wait, it would cause problems. So we're going to use a move counter, and technically it's going to get set to dice roll, but then it's going to be the one that we manipulate. So we're going to come down here, and where we have our key press, where we have dice roll. We're going to set move counter equal to dice roll. And then inside of our functions, inside of this while player 1 move 2, we're going to add another level of this. And we're going to go ahead and just delete out this guy for now. We'll get back to that in a couple seconds. And we're going to say, hey, while move counter is less than 0 or greater, oh my gosh, I'm so sorry. While move counter is greater than 0, do, and then end. And we know every time it goes through whatever we're going to have in this middle of this while loop, we want it to decrease move counter. So move counter equals move counter minus 1. So now inside of this whole move counter thing, before we decrease move counter, we're going to check our flow setup. So we're going to check to the right. And this is arbitrary, so you could check to either way. And this is where we're going to use else if statements. And this is just specifically so that it doesn't, once it finds it, it can just go on to its next life. So we're going to say, hey, if flow setup, so that's our flow chart, and our player index, so right now that's 13, equals 1. So if we're moving to the right, then all that means, and we can say end because eventually we're going to get to an end. Then all this means is that we're going to say, hey, player index, you need to increase by 1 because we're moving 1 over in our array or in our table. So player index equals player index plus 1. And we also need to move the position of the player, so we can say, hey, player 1x equals player 1x plus 64 because we're moving to the right. And then we're going to say, but hey, if you didn't see that we're moving to the right, let's check if down. And we can say if, or not if, we can say else if, because this is how they write their else or their if else statements. Other languages we use if else. Some languages you use elif. This one uses else if. So else if flow setup player index equals 2, then we're moving downwards. So this is where our indexes change. So player index equals player index plus 12. Because if we're moving down, we're moving a whole section. So, if we were here, this is 1, this is 12, this is 24. So we're moving down a whole 12 places. So that's where our new player index is. And then we want to say, hey, because of that, we're going to say player 1y is equal to player 1y plus 64. So that means that we're moving down. So the next thing we got to check is if we're moving up. So again, else if flow setup player index equals 3, then player index equals player index minus 12. Again, it's just the opposite of this guy. So it's going to be literally the same. We're going to say player 1y equals player 1y minus 64. And then the last thing we need to do is we need to check left. So we can say else if, and the reason why we're not just saying else here is because if we just said else, we'd also start going left if we hit a 0. Or if we hit something weird. If we somehow manage to get out of bounds. So that we don't get out of bounds, we're just going to make an else if statement. So else if flow setup player index equals for then player index equals player index minus 1 player 1x equals player 1x minus 64. And we still have our move counter, and we still have our player end. So now we can go ahead and say, let's try this out. Let's stop this from running. And let's run it. Let's see where I have the errors, because we all know there's gonna be one. Like I said. So this says, right there. So this says syntax error, unexpected symbol near the equal sign on line 110. So we can see that that was an equal sign that shouldn't have been there. So we can stop, we can run. And so now we don't have any errors. So when we click the space bar, does it do what we're supposed to do? Well, it didn't move 1 to the right. It didn't move 3. It didn't move 2. So what's happening? So now we've got to go in and say, hey, what are you doing? So the issue is right here. So I've said player index everywhere. And I haven't said it needs to be player 1 index. That's all we've said. So basically this is just checking nothing. Because it's nil. So all we have to do is come in here and change this over to 1s. Again, those of you who take me for class, you may notice that sometimes I trip over when I'm talking while coding. Sometimes I'm okay with it, sometimes I'm not. And again, this is not how I would initially do it. I would just have a player index and I would set it up. But let's see if I manage to find all of those. So there we go. So see, we moved 3. We moved 1, 2, 3. We moved 2. We moved 2. We moved 6. We moved 2. We moved 1. We moved 5. 5, 4, 5, 4. And if we keep pressing the space, now that we're on this one, which doesn't have any kind of movement direction, it's just going to stay there. So we can now get through this maze. We now know that we're going to be able to navigate, I keep saying maze, you guys know what I mean, this path. So we can now navigate. So that's what we needed to do. So if you look at the printed version, I also included print statements that actually show whether you're moving up, whether you're moving to the left or right, and what the move counter is actually at. And that was debugging. That was purely debugging because I ran into an issue where I'd managed to write something really silly, and I can't even tell you what it is at this point. But the point was that I was subtracting wrong. I'll just go with it that way. It was like 4 in the morning, and yeah, life was not going well. So now what do we do? Well, For clarity's sake, we're going to still keep this whole idea of player 1 and player 2 and player 1 and player 2 move, but we're going to also add another one called, hey, first move. And this is going to have to do with who's moving. I know that sounds like counterintuitive or like too many things, but basically it's going to help to switch, especially considering we start with this dice roll equaling 0 down further. So we are going to come inside of our Love Press, and again, if you're me, I do a lot of this kind of stuff just so that I can separate functions and things like that. There's actually really good reasons to put extra spacing between things, because you can find more things, and Lua is really forgiving about spaces, and it's not like your computer actually understands spaces anyways, at least not really. At least return keys. Other languages do have spacing issues or tab issues, but return keys it tends to not have issues with as much on certain languages. Lua is one of those languages. But so inside of LovePress, we're going to create an if statement, and it's going to be all the way down at the bottom, and it's basically going to enclose this if player 1 thing, so we're just going to put it here. We're going to actually just delete this guy right now. So underneath move counter, we're going to say, hey, if first move, and if it hurts you to just write it that way, you can say hurt move equals true. But it's understood that this is a Boolean, so it knows this is, true or false. So we can say if first move, then end. And here we're going to say, hey, yeah. So that means that player 1 move equals true, and player 2 move equals false, and otherwise, so else, player 1 move equals false, and player 2 move equals true. And again, in my example, there's a print statement, so just don't worry about it. Again, I was testing out a few different things because again, it was like 4 o'clock in the morning and there were problems happening. And again, it all boiled down to me forgetting variable names and misspelling things, so it happens. It happens a lot. So now we are going to go ahead and see about adding in the player 2 information. So basically we're at functionality now. The only thing we need to do is we need to add in the player 2 stuff. So player 2, and I'm sorry for that weird kind of transition, I had to take a phone call. So player 1 move, we have all of this stuff, so now we have to do player 2. And all we need to do that is to kind of copy and to figure out where the end of this is, which is there. And we're going to copy that, and we're just going to do that. And again, this is one of the things that pains me because we could do it more efficiently by just doing a function and calling the function per thing. And all we're going to do is change any of these 1s over to 2s. And because we've already created that switching mechanism inside of our dice, it should automatically work. And again, what I'm showing you is one way to do it, and it's definitely not the best way to do it or the most efficient way to do it, but hopefully it's an understandable way to do it, and hopefully it gives you ideas for creating things on your own, which is kind of the whole point, or was kind of my point, was to give you something to start thinking about and something that you could start thinking about how it would actually correspond to maybe something that you want to make. So if I click play, and I haven't royally mucked everything up, so the purple guy moved, the purple guy is still moving. Why is the purple guy still moving? So because something's happening here, I haven't reset a variable to get the green guy to move. So what I need to do is I need to go back in and figure out what I'm doing, and the good possibility is that I've managed to not copy something that I was supposed to copy. Let's see. If first move, then player one move equals true. Oh, derp to derp. This is totally not what this was supposed to be. It's supposed to be first move equals false. And first move equals true. That equals true. So let me actually make sure that I set that correctly in my notes. Okay, yeah, I just, again, like you saw, I mislabel variables, I go too fast, I think about things or I don't think about things when I'm typing, so now, again, if I haven't done anything wrong, and that's how that switching mechanism should work. So there we go. So now we have purple and green moving back and forth. But the one thing we don't have yet is like green technically won, right? So we don't have anything saying, hey, he won, stop everything, he won. And honestly, that's relatively easy. So what we're going to do is we're going to come up to our load, remember our very long load. And if you're in REPL and most other languages, you can actually make things smaller if it's a function or a table. And so we can collapse all of this stuff and we can actually come in and change a few things. So we're going to come over here, and we could put it down here, we could put it at the very end where draw points are, it just depends. And remember that in Lua, basically, your variable has to exist before you call it, so everything has to exist in order. Go with it that way. So let's create a game over variable, and we're going to say, hey, right now, game over is not happening. Game over is great. And then we can say inside of our update right here, we know that this tile equals end. So that's like where we win. We can say, hey, game over equals true if we're on this tile. So we can either move if you want to, so that we move off of here, or we can just kind of leave it there. So the big thing is that if you landed here, you'd still have to take one more turn. So it just kind of depends on how you want to do it. Yeah, it just kind of depends on how you want to do it. So what we can do is we can say, hey, we don't even really have to move any of this kind of stuff. We can just stop. And so instead of this, what we can say is we can say game over equals true. And then we can say, let's create a new variable called winner, just so that we can save the text of who won, and we can say player 1. And then we can come down over into our player 2 and do the same thing, where we can say, hey, game over equals true, winner equals player 2. And this is a way you could actually ask the people who are playing, you know, enter your names, etc., and you could store them and get them here. But it just, you know, it depends on how you want to do this. And again, because we know that this is going to be a left check, we could always check, hey, if this next tile is that one, then that's where we trigger it. But we can also say, hey, trigger it here, and then when they next roll, they'll win. So just, again, logical, little tiny logical things. You got to figure out how you want to make them. I never claimed this was going to be perfect or great. I just said that it was hopefully a little bit understandable. So now that we have that, we need to get it so that, you know, pressing the spacebar doesn't move anything after one person is won. And what we can do is we can say, you know, we can check first if it's game over. Or we can check after we press the space key. It's up to you. So we can say, hey, if game over equals false, or we could say if not game over, it's up to you, then, and we're going to put all of this in there. And then we're going to have to remember your end statement. And the other thing we're going to want to do down here is we're going to want to break, because we're not going to want to actually check if we can move anymore after we win or after we win. So we're just going to put a break statement in. And that just says, hey, fall out of everything. Stop doing your thing. So break. And now, ooh, that's not right. Hold on. Again, I'm so sorry. I 100% got ahead of myself and messed this up, because we still need to do this whole flow thing. We just needed to add another thing. So let's just undo all of this stuff, because we actually want that stuff there. It's not when this equals 4, it's when we can add another if statement. So right before this move counter, we'll do one more where we say, hey, if the map setup, so the initial thing that we created with just the numbers, if map setup player 1 index is equal to 4, then. And that's where we're putting our game over stuff. So game over equals true, winner equals player 1, break. And then we can copy it over down into here. Just switch these over to 2. And now we should have what we're supposed to have. And then again, we're just gonna write these things out. I'm just gonna tab them over. And so hey, if the game isn't over yet, yeah, the spacebar still works. And now, you know, it'll stop once you get there. And we can run it to make sure that I haven't broken anything yet. Because wow, I made that giant mistake. And are we going to actually run? No? Okay, stop. Run. Okay, so let's see if I broke everything. So see, so our purple player is now the winner. The green guy can't go any further. Everything is frozen. So we know that we've done what we're supposed to do. And again, you could have added in a print statement, which is what I initially did when I was testing this out the first time through. And that'll help you go through there. But what we want to do is we want to actually, you know, we want to write that we actually, you know, that who won. That's what the whole point of having that variable is, right? So we can come down to the bottom, and there's a few different ways that you could do it. You could switch over to a brand new scene. You could make everything go away. You could add a new graphic. You could add just text. And so what we're going to do is we're just going to add text because it's easy. Honestly, it's because it's easy. So, and I've taken up over an hour and a half of your time, and I'm sure nobody really wants to listen to me talk this long. So if game over, and again, if it helps you, you can put equals equals true. Then int, we're going to say, hey, love.graphics.set font, because we want to make a big font, and we want to make it 100. That's not what it is. Okay. It's love.graphics.setFont and then love.graphics.newFont 100. There we go. That looks right. And then we have to say, you know, print our text. So there's a few different ways. If you guys have used print before, there's just printing where it prints at X and Y, and it just you just kind of fiddle around with it until it works. But there's also a way that you can kind of create a text box, and then you can even justify inside of the text box. So we're going to use that version. And to do that, we say love.graphics.printf. And that's formatted print. So then we're going to say the text we want to print is, the winner is, and then we want to concatenate. We want to add in that winner value. So we're going to put a space so that we have a space between it and what the winner value is. And we're going to do 2 dots. Other languages use a plus sign or a few other different symbols, but we're going to use 2 dots because that's what Lua uses. And then we're going to say winner, so that's the variable we need. So then we're going to say that we want it to be at 0. We want it to be at 0 and in the X and the Y. And I'm sorry, I've got another phone call. Okay, sorry about that again. So we're going to say, hey, where exactly do we want to print this? So we want to print this, we want the box to start, so the top left corner kind of to be 0 and at 200, just because we do. And then we want it to be a maximum width of 800 because we want it to be the size of the screen. So of course we could do love.graphics.getWidth if we really wanted to get that value, but we know it's 800. And then we can tell it that we want it to be centered. So we're going to say, hey, center. And now, once game over happens, it should show us if it will start. And you can tell sometimes random isn't quite as random as we would hope it to be. If you press the spacebar too quick, like too close to each other, it'll like land on the same value. And we can see the winner is player 1. So that's all we were going to do. That's it. I mean, I know that seems simple, and what about, you know, what if you wanted to replay it? What would we do then? And there's a few different options. You can actually pop up another text that says, hey, press this one key to do this thing. Or you could create a whole new scene, or you could just not care and close out of it. It just kind of depends on how you want to do it. Now, there's also a really great function called love.event.quit restart, or love.event.quit, and then it's got a parameter. And if you leave that blank, it'll automatically close out of things. But you can also use restart, and it'll reset all of your values back like you've completely freshly loaded the document. And that's really what you want to do. Because otherwise, if you manually tell it to start again, then what's going to happen is that you're going to have to reset all the values manually. So using love.event.quit and using restart is going to be so much easier for you. So just remember that that's a thing. And that's written inside of the written document, which I again will link for everybody. And the other note, like I said, that I wanted to talk about was the fact that originally what I planned to talk about again in this video was to talk about, make some of these tiles special tiles. So maybe if you landed on the one with the diamond, you got to roll an extra time, or it meant that you lost a turn or something like that. And that, of course, gets more complicated depending on what you're wanting to do. And, it's all up to you how you do it. So this gives you a strong basis for kind of how to set this up and how to work with this. And it even kind of helps you, or could help you, if you were trying to make a maze. It uses kind of the same principles if you're trying to direct players to go through places. That being said, does it work for everything? No. Is it the smartest way to do it? No. But it is a more understandable way to do it. Now, what I want to do and what I'm hopefully going to get to do, it depends on how much time I have this week and what other things that I need to get done. I want to write a version of this using functions so I can show you how we can simplify a lot of things and make at least our load, update, and draw look a lot cleaner. So, those of you who are in my class, you know where to find me on Discord. Those of you who are not in the class and have stumbled upon this video, if you do have a question, send me a message, that's fine, or comment. I will hopefully see it. And I will link the finished version, so I will link the original version of this document, of this REPL, as well as the written version of this tutorial, because I know some of you read better, some of you listen better, some of you neither works, and that's okay. For those of you in my class, continue working on your games. Saturday will be a lab. And hopefully, on top of doing the function one, the next one that I want to do is kind of a scene switching tutorial, so that you guys can see how to make pseudo buttons and scene switching and things like that. Currently I can show you. It looks like because I started on this one and then I realized that maybe this wasn't the best one to show you guys yet, to show you some more functionality stuff first. So we have chickens. Again, you can see where my font's not quite working like it's supposed to, but if we click this play button, it actually starts the game. So, and right now it still has an event quit, where if we just hit the bottom, it'll go to nothingness. So I can show you if we switch it over. Oh, maybe I don't have event quit in here. There we go. It's right there. We can come in here and we can say restart. let our chickens fall. And again, you can see some graphic issues because of the way that REPL is, that you wouldn't maybe see inside of an actual game. And it's going to reset itself. So now we're back to the start page. And that's kind of how reset works. So if we click play, we're back to chickens falling from the top. And it's that easy. It really is that easy. So, alright. It was good talking to a screen. And hopefully this is helpful for somebody or interesting for somebody. And I will see you next time. Or not.